So guys, last class, we started showing the notebook and how a notebook works. If you remember, we can write down text and we can write down code in the same area, and we can keep the code for explanation or for documentation, and even for displaying the results that we want. And we can also write code, and the code is executed as soon as we press Shift Enter, or if we just click in the play button. One thing that I didn't show you last week, and I think it's important, is this number that we have at the left of each cell, and it shows us, I cannot show here because when I put the pointer of the mouse here, it hides the number, but here we have number 1 and here we'll have number 2, and this is not the order of the cells. This is the order of the execution of the cells. So that's one thing to keep in mind when you are trying to write your own code. Okay, because for example, if I rerun this cell, it will become number 3. And it's the order that the computer will remember the variables, for example, that we are assigning. So that's important when working with Jupyter notebooks or any other interactive environment like this one. If we were developing in a language without being interactive, it was not a problem because everything that we would put here, for example, A equals to B equals A times 2, for example, would be executed in the order that they appear. But in this case that we have Jupyter Notebook, we have to take double care about this. Okay, so maybe some of you can have problems when trying to run some code because in the memory you have the wrong value or the value that you are not expecting to. Okay. So just a quick recap. We saw the basic types. So we had the numbers. We saw integers. We saw real numbers. We saw how to check the type of the number. We saw a lot of different arithmetic operators. For example, addition, subtraction. We saw other operators like exponent or the floor division. Also, we saw the comparison operators. This is important for you to know, for example, the difference between 1 equal to 2 equals. When I put 2 equals, it means the equality operator to check if both sides are the same. If I use just 1, it's not the equality operator, it's the attribution operator. So it tries to put what is in the right to the variable that is in the left. Here that we don't have a variable, it will probably raise an error if I try to execute. Okay, so this is also important to know. Going on, we saw the strings. So strings is just a collection of letters, and it doesn't have any meaning. For example, if I just create a string with 5 plus 2, it returns me a string. It doesn't return me the result of 5 plus 2. That's also important to know. If I try to use comparison operators in strings, it behaves a little bit different from if we are operating on integers or Mariana has just joined. Hi, Mariana.
Hi.
Oh. Okay. Yes, it's really low, the volume, but we can hear you. We were just doing a recap from last class. Okay, so while we were waiting for you, we were just reviewing the first notebook to see if we had any doubts. Okay, so no new material until now. Okay. So, as I was explaining, the comparison operators behave differently when we are operating with strings than operating with integers or other numbers. And then we saw how to create a variable in Python. It's really simple. We just use a name and we use the attribution operator, that is the equal, and then we put anything that we want on the right side, and it will be stored in the variable that we are creating, and then we can use all the operations that we have learned with the variables. I don't know if I explained it correctly the last week, but basically we can write anything as the name of a variable, okay? As long as we don't have a number in the very beginning. It doesn't accept. So I can create a variable with a number at the end. For example, I can write number underscore 2. And now Python understands that number underscore 2 is the number 2. Okay? So this is the only constraint we have when creating a variable in Python. We cannot begin the variable name with a number. Otherwise, it's okay. So after that, we saw the lists, how to create a list. I showed that to create a list is only put a collection of numbers or any other data types inside square brackets, and then a list is created. It's a form of creating variables with more than one value in Python. I saw how to create this list with 6 elements. Now we see an error that occurs because of the thing I just mentioned at the beginning. We have to pay attention for the order of execution. If we don't have anything, any number in this cell here, in this position, it means that this cell has not yet run. So for Python to understand that LST is a list, I have to run this cell, so it's run now, and then we can check the length of the list. So we have 6 elements. Okay, and then we learned about indexing and slicing, how to access object members. Additionally, we saw how to access, for example, string members. We can just put a point just after the variable name, and then it opens for us a lot of different options. For example, if I create S, let's create again. And I type S point, it will give me all the methods or all the functions that I can call for this object string. Then I gave some examples, for example, to lower the capitalization or swap the case. Okay, going on, we saw the basic flow control, if statement, while statement, and for statement. The if statement is just if else. Do never forget that we have to indent the block of code so it can be correctly understood by the interpreter of Python. Okay, it's different from other language that I showed you. Other language, for example, you can put something around the block, but here in Python, we just use the indentation. So if we miss this indentation, for example, if I delete one space here, it will raise an error, an indentation error, because it's not correctly indented. Okay. What else? So we saw the if, elif, and else. We also saw the while statement. The while is a loop, is an endless loop, is a loop that ends only when this condition is not met anymore. So as long as this condition is met, the loop continues to run. And we saw different things that we could do using this kind of structure. For example, returning the numbers that are divisible by 3, or, well, for example, counting to 100, or creating a list. It's another thing that we saw how to do. You can create a list following certain logic that we create. Okay. The for statement was the last one we saw last week. It's really important. We use it a lot. We use more than the while, for example, in Python. And the biggest difference from the for loop in Python to a for loop in other languages is that the for loop operates only on lists or on any object that is iterable. If it's not iterable, we cannot run a for loop. So here, I showed you this last week. Here we cannot do for I equals 0 to 100 and print I like we did or like we do in other languages, because it will raise an error. Okay, it doesn't work like this. We need to pass something that the Python interpreter is able to iterate through. So the list is something that is iterable. It can iterate. So we can understand that we have in this LST, we have LST 0, the first item. It understands that we have LST 1 is the second item. Okay, this is really important because we are going to use it a lot, and it's necessary to know these basic concepts to, for example, solve the problems, the exercise I left for you to do. Without these basic blocks, we cannot follow and do, for example, this exercise. Let me see if I forgot to show anything. Okay. And then to make it easier to iterate through a range of numbers, instead of creating a list, for example, if I need to iterate from 1 to 10, instead of creating a list from 1 to 10, I can just use this function, the function range, because the function range will behave as a iterable object. If I do like this, the variable I will be 1 at the first place, and will end at 9, because as I already explained in the last class, it never touches the last value, the endpoint on the right, the last endpoint on the right. Okay. Okay, let's go to the exercise. So last week, I'm going to change the lesson. I'm going to the notebook for lesson 2. Last week, we created these two lists. We used these commands here to create two lists, one with the day of the month and the other one with the daily rain. I run this notebook again, this cell. Okay, and this was an attempt I did to simulate a rainy month. Okay, so we have 31 values with the daily rain for each one of these values. And I asked some questions like the number of days with rain, the day of the maximum rain, and the day of the minimum rain, the total rain.
Mauricio, I have a question.
Okay, go
Can
ahead.
you scroll up a bit? Can you scroll up a bit?
What?
Yes.
Yeah, keep here.
What is the figure size 18 and 9?
Okay, figure size is just for visualization purpose. Yeah, it's just width. Here is width, and here
Okay.
is height.
Yeah, okay.
Okay, so it's just that because if I don't do this, I will have my graph like this. But
Yeah, okay.
we are going to have a class specific for matplotlib. Not yet, because if you don't know yet how to create an array and this kind of stuff, I will be using just the very simple concepts of matplotlib. So you can just memorize this one because it's important to increase the size of the graph. But okay. Any other question? No? Okay, let's go. So I did some answers that I thought of on how to solve some of these exercise, and then I wrote a part with Pythonic solution, and then I will show you the difference between the the solutions that we have here to solve these problems. So, for example, the number of days with rain. One day with rain, we can consider that is the day with a daily rain greater than 0. Okay, so one way to solve this question here is to just go through the daily rain and check for the rain greater than 0. If we find any daily rain with this value greater than 0, we increase the variable that I initialized with 0 here, that is called days with rain, I increase with 1. So in this case, if I run this piece of code, it will correctly return me 30 because I think I have only one value here with 0 in the daily rain. And we have 31 values in this list. Okay, so this is one way to solve this question. The other one is a little bit more complicated because it's asking the day of the maximum rain and the day of the minimum rain. To solve this kind of problem, what we can do, you can initialize 4 variables, max rain, the day of max rain, minimum rain, the day of minimum. But as we iterate through the elements in the list, the elements in the rain list, we have to check, for example, if I'm looking for the minimum rain, I have to check if the values that I have already found are lower than the current value I'm looking for. So the correct way to initialize this kind of search, if I'm looking for the maximum rain, I start max rain with 0. With the minimum number possible, I could even start with the -1, for example. That's an impossible value. And I start the minimum rain with the maximum possible value. There are other ways to solve this using the internal functions, but I would like to just show you how to do it the old-fashioned way because it's also important, and also because we are going to use other functions like zip, for example. Okay, so to solve this problem, we initialize these variables, and then we have to go through the list. To go through the list, we already learned that we can just do a for loop. So for example, we can do for rain in daily rain, and inside this loop I can do whatever computation I want. Okay, so in this case, as we are looking for the day of the month that the minimum rain or the maximum rain occurred, what we have to do here, or one possibility to do here, is to use the zip command. The zip command will get two lists. Day of month is one list and daily rain is another list. And it will iterate through both of lists at the same time. So for example, if I do like this for day rain in zip, day of daily rain, print, I will print, I will teach you how that works. I would like to print, for example, the day, the corresponding rain. But if I do like this, it will not give me a good result because everything will be mixed up. One thing that we can do in Python that is new to Python 3.6, I think, is the formatted string. I can write, for example, day and put inside curly brackets and the variable that I would like to compute, that is day, had or rain on day was, then the other variable. If I do like this, the result will not be as expected because remember that the Python interpreter understands everything that is inside the quotation marks as a string. So for the interpreter, everything is a string, day is a string, and rain is a string. And the new thing that they created in Python is that we can put a letter here before the string to tell this string is a formatted string. So now this is a formatted string, and then when it finds anything that's inside curly brackets within the string, it will try to solve. If I run, I can see rain on day 1 was 17, rain on day 2 was 72, rain on day 3 was 97, and so on, so forth. Okay, and here, just for you to understand correctly, I can put whatever computation I want. So if I would like to divide the day by 2 and to square the rain, no problem. Before converting these to string, it will do whatever the computation I put inside the curly brackets, like this. Okay? So this is a very fancy way to display results in Python. Okay, now that we know how the zip command works, just to remind, zip, I write 2 or any lists. I could write another list tree here, and it will iterate together the lists, and the results for each iteration will be stored in these variables day and rain. Okay, so that's how it works. I will delete this cell and let's go back to the solution. So for day rain in zip, day of month, daily rain, the same thing that I did before. If rain, the rain of the iteration, is greater than the max rain, remember that max rain we are initializing with -1, so any rain that we have in this list will be greater than -1. I will update the max rain to rain, and I'll set the day of max today to the variable day. And for each iteration, we will do like this. And we'll do the same if rain is lesser than the minimum rain that I initialized with a really great number. Okay, And I do the same. I store the day of the minimum rain. Afterwards, at the very end, I will just display the day of maximum rain, the day of minimum rain. Okay, the results are 13 and 23. So let's check if 13 is the day of the day of max is 13, day of min is 23. Day of max is 13. So we have 10, 11, 12, 13. This is the maximum rain. And 23, 20, 21, 22, 23 is our zero rain. Okay, so this we can write this kind of code to do to find values in a list or in a series that we have. Okay, so to create a total, we'll do the same. We'll go through our list, and for each iteration, we will be adding the value of the rain of that iteration. Of course, that we have to initialize this variable before entering the iteration. For the mean rain, we can use the value that we have just calculated before and divide by the daily rain. By the daily rain, sorry, divided by the length of the daily rain. Okay, and then we have the mean rain for this month. Okay, so this is very old-fashioned way of doing things. Nowadays, we don't. It's important for you to understand that it's like this that we have to develop the code and to create algorithms. Nowadays, of course, that we have functions already created and already defined that are much simpler for us to do these kind of operations. But it's important because for any new code that you need, you will have to create probably some kind of logic like these that I'm showing here. For the sort, I also asked for a challenge that was to order the days according to the rain precipitation. For example, if brain, okay, brain. So, for example, if the greater rain was on day 13 and then on day 7, and I would like to put this list in order, and then I created from my brain a sorting procedure for this. I'll not go through this today in this class because it's complex. I would like you to, if possible, to take a look. And if you have any doubts on how this works or you don't understand, you can call me or send me an email. I can explain afterwards how does it work. This is a sorting or a sorting algorithm that we learned on some classes. Okay, this is the really simplest one to develop. But the output is really big if you if you see. It's really huge until it finds. It's not the most with the best performance algorithm to sort a list of values. I go just swapping each time I find a smaller number or a greater number. I swap the numbers, and I have to do this a lot of times with two force aligned here. Okay, so this is a little bit complex. I'm going to skip this, but if you are curious about it, you can just take a look and ask me afterwards. But now we have the Pythonic solution. If you look for solutions in the internet, if you Google or something that you are trying to do and you are not being able to achieve, sometimes you see this term, this notation here that is called Pythonic solution, because it's different or it's easier from the way we do in other languages. So I also wrote here the Pythonic solutions for the same questions. So if one of you has gone to the internet to try to find the ways to answer the questions, probably you have found something similar to these solutions here. For example, the first question, I forgot. What is that? The first question. Let me put these questions near the Pythonic solutions. Number of days with rain. I forgot to maybe to put. Now it's here. The number of days is rain is here. Okay, this one let me just write down here for you. Day of minimum rain. What I'm doing here, we do have a function that is the min and max. We also have the max functions that operates on a list. So if we type, for example, min daily rain, it will give me the minimum value of the list on the list. But it's not the answer I'm looking for, because I'm looking for the day where this daily rain occurred. So to check the day, I can look for the index of this daily rain. If you remember correctly, the daily rain is a list. I will put in a string just for the visualization to be easier. Daily rain is a list. The minimum value is 0, but I would like to know where is the 0 in this list. And for that, we have another function that is called index. So I can write daily rain dot index is there. If you don't remember what is the index, you can just put a question mark just after, and then it returns me the first index of the value. Okay, the first item, of course, if I had 2 zeros, it will return me just the first one. Okay, but here we have just 1 0, no problem. If I put daily rain index 0, it returns me 22. And you might be asking yourselves that 22 is not the correct answer, and you are right. But the problem is that our day of the month list, it's from 1 to 31, but remember that the index of 1 is 0, the second index is 1, because it's 0 based, the indexes of a Python list. Okay, so here I have the index where the minimum rain occurred, and to get the I know it occurred on index 22, to get the day of the month, index 22. And here's our answer, 23, as we found before. So if you want, that's another good thing that we can do in programming. We can just write functions inside of functions. So for example, I can put the minimum daily rain inside here, and then I can get everything and put this inside here. Starts to solve. It will solve first the minimum daily rain, it's 0. And then we'll solve the index of 0 is 22. And what is the day of the month on index 22? 23. So in just one line of code, we can answer the day of the minimum rain. If we compare to the first solution that we had here, yeah, it was a little more complex because I put minimum and maximum in the same loop. But Even though if you try to cut down here to just one, we need a loop, we need an if clause, we need a lot of stuff. And we say that it's not Pythonic. This is a Pythonic code using all the capabilities of the interpreter to answer a simple question like this one, the day of the minimum rain. Okay, so we can do the same, just changing minimum by max, and we can find the maximum rain, the day of the maximum rain, 13. Okay, the mean, instead of looping through the list, the daily rain, we will just use the command sum. The command sum will add up everything in the list if they are numbers. So sum daily rain. It will return me the total rain on that month. Okay, we can also, for example, it doesn't have any meaning, but we just to show we can sum day of month to return me a number that doesn't have any meaning, but just show you that it works on any lists that have only numbers. Okay. If you have any doubts, you can just put a question here in the chat or raise the hands. Okay. Don't be afraid of asking. Here's another solution. I'm not explaining this one because here we use Lambda Functions. It's a more advanced topic. But just to show you that we could, for example, to find the number of days with rain, we could also use in one line of code. That was my challenge, to write all the answers in one line of code. And the last one, that also uses a Lambda function, is to sort. So instead of writing this big code I had to write here and waiting a lot of time, if I show you, it writes a lot of output to run to create the final list. We could sort the list using the command sort of Python. So for example, let me just show you this one. I have day of month. It's in ascending order, called sort, and I can put reverse equals true. And the result, where is the result here? Sorry. Okay, it's already in descending order. Let me just display day of month. It in a string, just to make it easier. And it's inversed my list of days of month. Of course, to do this, here I asked a more complex thing, because it was to sort the days of month according to another list. So that was more complex than just sorting a list. But it's here in the notebook. As we go on in the class, I can come back here and explain you exactly what is the Lambda function doing. But for the moment, just be aware that these are the Pythonic solutions for those questions I wrote there. Okay. So any questions until now? No?
No.
Okay, let's start with the basic types part 2. Basic type part 2, we are going to start talking about sets. Sets are used to store multiple items in a single variable. Sets, one of the 4 built-in, it says data types here in W3 schools, but I prefer calling it structures, because data types we can understand that there are the integers or float numbers, and these are the structures that Python offers. The others are list that we saw, list that we saw the last week, tuple that we're going to see today, and dictionary that we're going to see today. And what is different about a set? A set, first of all, to create a set, it's similar to creating a list, but instead of using the square brackets, we use the curly brackets around my elements. Okay. But in a set, I cannot have repeated values. So for example, if I try to repeat a value here, the value is not repeated in my final set that has been created. Another thing is that the set is unordered. So for example, if I try to access the first item of the set, it raises an error because it doesn't know what is the first item in the set. For a list, that works. It understands what is the first and the last item in the list, but for a set, this doesn't exist. So I cannot try to access an item in a set like this indexing. But set will have other functions or other capabilities to work with sets. For example, if I define another set called mySet2, and I put again the value banana, and I create other fruits like kiwi and pineapple, I can use commands that exist about sets. So for example, I can use mySet.union, mySet2. If I do the union, I have just one banana, one cherry, one kiwi, one pineapple. If I try to create a set that is the difference, it's one set minus the other set. I can use mySet.difference, mySet2, and it creates mySet3. And if we take a look at mySet3, it's apple and cherry, because it's the mySet minus apple, banana, and cherry minus banana, kiwi, and pineapple, as banana is the only intersection that we have between these two sets. My answer will be apple and cherry. You can also do the intersection, for example, set dot. Here we have all the set functions. Intersection, yeah, we have intersection. Probably we'll have just banana in the intersection. That's useful for some case. Mariana, you raised your hand. No?
I always
Mariana?
we
We are not hearing you. Can you type here in the chat, maybe?
Not?
Now we can hear.
I would like to ask if I have to begin the function with my set, or I could put only set.
You can write whatever you want. Can you just cut your microphone, because it's giving me a audio? Yeah, great. Thank you, Mariana. Let's understand this very well. Okay, set is a function. It's an internal function of the Python interpreter. If we type set question mark, we'll have a little help here of what is a set. Builds an unordered collection of unique elements. Unique. That's why we don't have repeats here, repeated elements here. Okay, so this is called set. When I write this expression here, my set2 equals set, what is it doing internally? It's here it's creating a set, like the doc explains me, and I'm putting the result in this variable. So this variable I can call, or I can name it, or I can label it whatever I want. So for example, if I call it Mariana set will work. And from now on, Mariana set is a variable in the Python brain, for example, in the Python core or in the Python memory here. Okay, if that's not entirely clear until now, we can also use, this is a new function, I don't even know if it works correctly. Okay, it works, great. This is a new function of Python. I don't know if it's available if we install Python in a desktop, but here in Colab we have it. We can see all the variables that have been defined since I started writing any code or executing any code in this notebook. Okay, so that's interesting because here we can see that Mariana set is a variable. The type of this variable is set, and it has 3 items. Okay, is it clear?
Yes, yes.
Okay.
Thank you.
Great. So it was good the question because I forgot that we had this function here in Colab to use. So that's interesting to use. Guys, can you hear me? Because my screen froze here, and I need just to unplug.
Yeah, I can.
Yeah, we can. Yeah.
We can.
I have a question.
Hello?
Hi. Can you-
Okay. Sorry, guys. I had a problem here, and everything went down. I don't know where is my I don't know where is my interpreter. Let me just find it. 1 second. Can you see my screen or not?
No.
No?
No.
Okay, no. Okay. Let me start to. Oh, how can I do this? How can I do this? Okay, I have to share again. Let me share the screen. Share desktop. Can you see now? Is that okay?
Yes.
Yes.
Okay, great. Just give me 1 more second because I have to fix another thing here. Here and here. Okay, let's continue. So as I was saying, that's good because now we saw this other possibility here, this other functionality that we have in Google Colab to see what are the variables that we have in memory at the exact moment. And that's a cool thing that Python gives us. Okay, so we can operate on sets like this. As I told you, we cannot.
Wait, Mauricio, you didn't show the Google Colab.
I didn't. What?
You didn't show the Google Colab on the screen. There's we cannot see anything on your screen.
Really? I don't know what's going on because I started to. Okay, let's try it again. Okay, maybe now.
Okay.
It's
That's
working.
good.
Okay. Sorry, guys. Okay, so going on here. Okay, as I told you, it's unordered, so it's impossible to do indexing in a set. like this one, because it raises me an exception. But
Mauricio,
okay, yeah.
I have one question about this part you mentioned about unordered. Can you repeat, please?
What is unordered? Okay.
Third one, because I didn't understand why it's necessary to put these and why my set is 0.
Okay. Let me to explain this better. Let me if you remember well, last week we created a list, and let's call it, let's see, Michelle list. We have other fruits, for example, okay? And we have okay, choose the 3 fruits that you want here, Michelle.
Orange, pineapple, kiwi.
Okay, so we have 3 items in Michelle's list. And let's imagine, for example, that these are the fruits that you eat all the weeks. And so we have 5 days in a week, in a business week. And then on Friday, you repeat the orange, okay?
Okay.
So we have orange 2 times. Last week, I showed you how to access items in the list. So the lists, they will always remain in the same order that I typed here, always, no matter what I try. For example, if I write other codes, or if I write a loop or anything, if I don't change the list, the items continue to be in this order. And we can access the items, Shelley list, indexing the items. If you remember, we did this last week when I explained about indexing, and I also explained about, for example, slicing. You remember that we could use these numbers to access one item or a slice, okay? And also, just to be clear, we could also count backwards from the last one to the beginning. Okay, so the last one is orange. The previous one was kiwi. Great. But imagine that, Michele, you are going to create your shopping list. You are going to the supermarket, and you'd like to pass the shopping list to your husband, or you need a shopping list. Okay. This list will have duplicates. We could create, for example, a set of Michele's list.
Okay.
If I create a set using Michelle list as a base, you see that orange, it doesn't, it exists. It's not duplicated anymore, but I cannot guarantee the order. If we look here, the first item in the set is kiwi, and it was the third item when I created the list.
Yeah.
So that's what we call an unordered structure in Python. We cannot guarantee in your program that the order will be maintained. And it's not only that. What they did, they avoided you from indexing the set. So for example, if I take Michelle's list, I can index like this. But if I create Michelle set, that's this set, and I try to index, let's see what is the first fruit that Michelle eats in the week. So I will try to call Michelle set index 0. It raises me an error because it says that set, the object of type set, is not subscriptable. Subscriptable or indexed It's almost the same thing. Subscriptable is when we put these square brackets just after the variable to do something. Okay, normally, when you have an iterable, we do indexing. So we cannot index a set. Understood?
Yeah. Now
Okay.
I got it. Thanks, Maurice.
No problem. No problem, no problem. Okay, but here, this is an interesting thing. We cannot index, for example, we cannot say what is the item 0 of Michelle's list, or what is the last item of Michelle's list, but we can still iterate through the list, through the set. So if we put here Michelle set in a for loop, item is the name of my variable, Michelle set is the name of our set. Okay, we have 3 items there. We still can go through the items, but keep in mind that the order has nothing to do with the order that we have created. Look how interesting is this. Set. Look at this. Where is Michelle set? Michelle set is here. Okay. The first one, when we created, was orange, pineapple, kiwi, and orange. After, when I created Michelle set using Michelle list as a base, it was kiwi, orange, and pineapple. And when I tried to do a for command, kiwi, pineapple, and orange. So each time I run the program, I can have a different order for the elements in a set. That's why set is not so common to be used in Python, but it still has some useful use. For example, I put an example here. When I created the program that is water detect, that it detects water in a satellite image, and we have, for example, to download the bands. To try to find what are the minimum necessary bands to run water detect. For example, I have the reference band, or I have the clustering bands, or I have the thresholding bands. What I'm trying to say is that, for example, the band red can appear 3 times. Because I have red as the reference band, I have red in the clustering band, and I have red in the threshold bands. Afterwards, in the clustering bands, I have also the green. And so on and so forth. So I have a list of different bands. And the same band can be repeated. What I do, I create a set because the result will not have any duplicates, and that assures me that I will be reading just once the band of the satellite. Otherwise, I would be reading the red band of the satellite many times. Okay, so there are times where set is really useful. And the other thing that we can use with set is the in command. For example, I can check for an element if it is in the set with the in command. For example, I'm checking if cherry is in my set tree. It is. I can check if cherry is in Michelle set. No, it's not. Okay? Any doubts until now? Or we can go on. Mariana, following? I think Mariana has a problem with the microphone.
Yeah, I have. But okay, I will solve this after. But for me, it's good. I understand.
Okay, great. Thank you. So let's check another structure here that is tuple. This one is very used in Python. It's similar. You will see that all these structures are pretty similar For example, set is similar to list, is not exactly the same thing, but it's similar. So other commands that exist, for example, for list, we can use for set len Michelle set. We have 3, for example. Okay, so when you learn some commands for one structure, you can try to use the same commands for the other structure because it works. I don't know if we have min and max. Yeah, it has. So I didn't even know we had this for a set, but okay, you can just use the same commands or almost the same commands that we use in lists for a set. Okay, let's take a look at tuples. Tuples is just like, it's similar to a list. It's very similar to a list, but the difference I will write here so you can remember is that it's immutable. I will put it in bold because it's really important. It's not in bold. I don't understand why it's not in bold. I will do like this. Put this in bold. Now it's okay. So once I create a tuple, I'm calling it T. To create a tuple is just to put a sequence of elements inside squares. Okay, inside squares. Once I create a tuple, we cannot change the element. If we go to the list, I created a list. I thought it was Michelle list with four fruits. If I would like to change one element, for example, I don't remember if I showed this last week, but we can just index one element, for example, the last one. And we would like to change this one, the last one. Instead of orange, I would like to put grape. If I look at Michelle list now, it has grape in the very last element. So we can change the elements inside a list. If you try to do the same with a tuple, let's access the last item in the tuple. It's number 5, but I don't like number 5. I want it to be 6. And I try to put 6. It raises an error because tuple object does not support item assignment. So we cannot assign a value to an element inside the tuple. Okay? So that's another difference, important difference from tuples to lists. Type T. So it's a tuple that we have created. We can do in slicing as the list. And here, it's something interesting. If you do remember from last week, when I put the results separated by comma, and the result appears like this, that's because internally, Python gets this and creates a tuple. So that's the same thing. It internally creates a tuple. And why is it important? Because we can do something that is called tuple unpacking. For example, let's take the tuple T that we have created. 1, 2, 3, 4, and 5, and I would like to store these numbers in variables. Okay? One way would be variable A equals T0, variable B equals T1, and so on, so forth. That's one solution. Another solution that it gives us is this. A, B, C, D, E. Let's try. It accepted. We can see that we have the variables A, B, C, D, and E. They are all integers. We can check. E is 5. A is probably 1. So what it happened here, it was an unpacking. So it understands that that this tuple that is on the right side, it has to be unpacked for each one of the variables that I'm showing or I'm putting on the left side of the assignment. Okay, it does that automatically. It's just for to making it easier, the code. For example, I can write something like a comma b equals x comma y. If you understand that x and y are 0 and 1, now a and b are 0 and 1 as well. Other operations that we can do in tuples, we can also do in lists, but I didn't show you, but I'm showing you now, and you can do in lists as well. We can do, for example, addition. We can add a tuple to other tuple. Remember, I have here two numbers, integers, inside squares, so it's a tuple. I can add a tuple to another tuple. The result is the concatenation. So the result, concatenation of the values. So we have 1 to 5, that is the t, and we have 0 and 1. We can also have multiplication, but multiplication in tuples or lists, it will not multiply the values by 2. It will repeat the tuple 2 times or 3 times or any time. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That's also interesting. We can use this on our code as well. It's very new for Python 3.8 that this unpacking thing that I showed you here, it now works for any object that Python can iterate through. So any iterable is able to do the unpacking. So this is another example that I wrote. For example, if I have the employee is the list. For example, John, 40 years and a software engineer, and you'd like to assign name, age, and job. You can do like this using indexing, or we can do the list unpacking using name, age, and job on the left side of the assignment, and it will work. It's what it's doing here, it's unpacking the list or unpacking the tuple. Okay, that's really interesting. It can work even in strings because the string is an iterable. I showed you last week that we can find exactly what is this character here or the last one using indexing as a list. So we can also do unpacking with the letters of a string and put each letter in a different variable. Okay, I'm creating a lot of variables. It's becoming really difficult here. I will hide the left pane of Google Colab. Unpacking is this. I put here another material for you to take a look if you are interested in understanding more about unpacking. Another cool thing that we have in lists that is important because the code that we are going to see in Python can be written in this manner is list comprehension. List comprehension is just another way to create a list. So for example, suppose that we have a list already created, 1, 2, 3, 4, and 5. And I would like to create a list with the squares of each value. So we can create a new list. I can create it as an empty list, and I can go through the elements of my list. For each iteration, I can append. Append, remember, is to join an element at the end of the list. I can append one element to my empty list at the end of my empty list with the value of x. X, remember, is the pointer for my iteration here, the variable for my iteration here. with the squared, and then I create a new list. Okay, that's one way of doing. The Pythonic way of doing this is using list comprehension. List comprehension, I put the creation of the list in just one line of code. I do these 3 lines of code in just one. And the syntax is like this. I put the square brackets to indicate that is a list. I put a for loop here. And here is the element that will be created in my final list. So for example, what we'll do here, it will for x in LST, so for x equals 1, for x equals 2, for x equals 3, what it will do, it will square the x and put in a list. If I run this code, the result is exactly the same as the result we had before. Okay, we can do the same. We can just change the command. For example, if you'd like to divide our numbers in the list by 2, we can just use x divided by 2. And that's just another way of writing this, because as you will see, in Python, we avoid doing for loops. And it's not a rule, but it's possible to write an entire code in Python without any for loop, using these and using other ways to iterate through elements in a list that I'm going to explain, not in the next class because they are more advanced, but in Python we can avoid using for loops because for loops, they are not performatic, they are slow, and if we need performance, we cannot put the interpreter in for loops like this. Okay, so there are other ways of doing this. Another important thing that I'm going to show you here is that we can do unpacking inside a list comprehension. For example, suppose we have 3 students with each age, sorry, and I'll put everything in the same list. So my list is LST. I'll put this is student 1, this is student 2, this is student 3. The name of the student is the string, and the number is the age. You can pay attention that I'm writing tuples. Each item of my list is a tuple. Don't forget, if I try to check the length of this list, it gives me 3 because I have 3 tuples in the list. Okay, I don't have 6 elements here. I have 3 elements when I try to check the length of the list. Okay, each element is a tuple. That's the structure I have just showed you. I can do the indexing as we did last class. For example, I can type list 1 0. List 1 0, what brings me, it's the second item in the list, this one, and then the second index here is for the tuple, is the first item in the tuple. It returns me the letter B. Okay, everyone understands this syntax here? Okay, let's go. Now, let's do what I was supposed to do, that is the unpacking inside a list comprehension. First, before doing the unpacking inside a list comprehension, I will do the unpacking inside a for loop. Suppose that we would like to create, we have this list here, but I would like to create a list like this. The first item in the list is a string that says student A has student, name of the first student, has 11 years, and student B has 9 years, and student C has 10 years, okay? Let's imagine that we want to create a list like this. We can use our for loop. We create a list called student, it's empty, and we can do the for loop in our list, but we have two ways of doing this. Instead of putting the result here in item, and then item will be a tuple, and then to access the values here, I have to write item 0 and item 1 instead of this. If I do like this, for student, comma, age in list, what it does internally, well, first item of the list is a tuple, but it's expecting two variables here. So it does a tuple unpacking. So the first value comes to student, the second value goes to age. And then we can write the string as, not exactly as we did before, but we write concatenating the string. That's another way of creating the string. I will create a string like this. I will create a variable s. It's a string student plus another string. Remember, if I try to add two strings, it will concatenate the strings. Has string age plus years, and I will append this string to students. And if I run this code, my list that is called students has three strings. Student A has 11 years, student B has 9 years, and student C has 10 years. And I can put everything inside a single list comprehension like this. Remember, list comprehension, I put the square brackets, I put a for statement. My for statement is here. I'm doing the unpacking here because each item in the list is a tuple. So I'm getting each item of the tuple in these two variables. And here on the left, I put the elements that I want to store in the list, in the final list. And instead of doing this, concatenating the strings, I will use the format string with the student inside curly brackets student, that is this variable, is curly brackets age, the age that I'm getting, and then years old. So I created this students list in just one line of code. Everything okay until now? Any doubts? No? Okay. Guys, just one question before we continue. It's already 7:20. I think we have two options here. We could go and try to do the dictionary, but it's a little more. But this part's not very complicated, but afterwards it gets more complicated because of the examples. So I don't know if you prefer to stop here and then we continue, we start dictionary in the next class, or maybe we just start the basics of a dictionary and we see the example, the dictionary example in the next class, because I'm afraid it's already 7:22 and not to be so fatiguing. That was, I have some nice examples, but yeah. What do you have to tell, Mariana?
Are you hearing me? Yeah?
Yeah, we can hear you.
My suggestion is to start this new subject next week, because I think it's a lot of things to observe it, to understand, and
Okay.
For me it's good to begin a new topic.
Okay, the next week maybe. Anyone do you agree, guys? Anyone has?
Yeah, that's okay.
That's okay.
Mhm.
Okay, yeah, because I think that if we try to start the we could start, but just this really small part of dictionaries, because I really wanted to show you how to work with dates. I'll just give you an idea of what we are going to work the next week, but we are preparing a structure to store hydrological data, for example. We could store any other data with a time series. I'm creating a random stage for the river using a random walk. If you know finance, you know what a random walk is. I can explain you next week. But uh, we are going to create this graph, and it's a structure with three time series. And the exercises for the next class will be for example, to add up this series, considering, for example, if there are flows of the river, and we want to sum or to add these flows to obtain a third or a fourth flow, to check another station, this kind of stuff. So I think it's really interesting. I would like very much to show you these examples that I've created, but I think it will be overwhelming to to start today. I agree with Mariana. If it's okay for the others, it's already 7:30, almost 7:30. So one hour and 30 minutes. I think it's already good for. Otherwise, it's really too overwhelming to. But keep in mind that the notebook is here. The notebook for the lesson 2 is already in the repository, so you can just go there, and if you would like to take a look and see how things work, you can just go there and see for yourselves and rerun the cell. That's really important for those who are not used to programming. For example, Mariana and Michelle. For those who are not used to it, it's important to try to run the cells by yourselves. Otherwise, it's really difficult to 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 get all the concepts and to understand everything by heart. So it's really important if you go and you see and you need to get the errors for us to for example the next class maybe to see what there are the doubts and even try to redo the exercise from the last class, because there are some important concepts. What I'm teaching you here are the building blocks, what we call the building blocks for creating a bigger thing, a bigger program, or to understand how to call a program and this kind of stuff. So that's really important. Okay, so we can make this pause now, and we continue in the next week. Okay.
Okay.
Same
Okay.
same time next week. What do you think? Everybody agree?
Next week, yeah, next week maybe I cannot join. I go to Italy, but I will try to do it online. I mean,
Really?
everything is online, but I will try to do my best, Joyce.
Will be
I
fine
rem-
for me.
Sorry, Michelle.
It's fine for me next week.
Fine, same hour. Okay.
Yes.